Hello, Math 10C preppers. This is our last lesson of the week, so you get to have a 3-day weekend. How sweet is that? Today should be decently quick because we're just going to do diamond method again, which is the same thing we did yesterday. It is going to be a touch harder today, but we'll review how that looks. So let's look at this first question, a review from yesterday. It says to factor. Remember, factoring means to unmultiply things, right? To take something and write it as multiplication. So the first thing I want to do is I want to look and count how many terms there are. I notice there's one term, two terms, three terms. And our strategy for factoring three-term polynomials is to turn it into two binomials multiplied together. We then remember that when we have two binomials multiplied together, the first term of the trinomial always comes from these first two terms. So I know those are x and x because x times x will become x squared, which is the first term. The next two terms, however, in my binomials, I don't know how to get them. So that's why we have something called the diamond method. The diamond method is where you draw a diamond, and on the points, you're going to put numbers. The top of the diamond is your a times your c value. A is the number in front of x squared, which is 1. C is the value at the end, which is 4. 1 times 4 equals 4. On the bottom of your diamond goes your b value. Your b value is the one that's next to your x, which is right there, 6. The sides of your diamond are two numbers that you have to discover. It's two numbers that have to multiply to be the top number and add to be the bottom number. And just like yesterday, there's a typo. Holy Dinah, Mr. Kennedy. Like, get it together with the typos. So this shouldn't be a 4. This should be a 5. I'm always like one number off. I'm too tired when I'm writing these out. So you're looking for two numbers that multiply to be 5 and add to be 6. In this case, two numbers that multiply to be 5 and add to be 6 would be 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. Those numbers on the sides of the diamond, those are the numbers that would create these binomials. Like that. And we have now taken a trinomial and turned it into multiplication. We're going to do a couple more, so if you look down here, we're going to try it again. Whenever I factor two trinomials, I always get two binomials. The first term always comes from the first terms multiplied together. X times x is x squared. The second terms come from the sides of my diamond. If I draw my diamond, the top would be 21, the bottom would be 10. The sides of the diamonds are the numbers we're looking for. We're looking for two numbers that multiply to be 21 and add to be 10. In this case, 7 times 3 would be 21, and 7 plus 3 would be 10. So my answer is x plus 7, x plus 10. Like that. Beautiful. If we look up here, we now get this situation where before we start our diamond method, we actually look and we recognize that I could take a greatest common factor out. Right? I could divide everything here by 5, and then I would be left with x squared plus 3x plus 2. Then I can diamond method that and factor it. The 5 out front will stay out front, and when I factor that trinomial, it'll be two binomials. My first term always comes from my first terms. My second terms come from my diamond. I'm looking for two numbers that multiply to be 2 and add to be 3. In this case, 2 and 1 would multiply to be 2 and add to be 3. So this thing factors to become 5 times x plus 2 times x plus 1. like that. Last one here. Again, we're going to take a greatest common factor out. So I could take a 3 out of all of these. That GCF goes out front, and then I'm left with x squared plus 11x plus 24. This thing can then be factored again. The 3 will stay out front as a greatest common factor. That's a monomial. And then that trinomial will turn into 2 binomials. The first term always comes from the first terms. X times x is x squared. The second terms come from the sides of my diamond. The sides of my diamond are two numbers that multiply to be 24, add to be 11. That's 8 and 3. X plus 8, x plus 3. That thing is now factored. That should have all been reviewed from yesterday, lesson 2.5. Today, we're going to do a little bit harder diamond method, but before we do that, we're going to just do a couple multiplication questions to see something unique that happens. So to remember how to multiply, we use distribution. So I take my 2x, I multiply it by x to become 2x squared, and then multiply it by 3 to become plus 6x, and then take my plus 1, multiply it by x to become plus 1x, multiply it by 3 to become plus 3. My like terms are right there. So it's 2x squared plus 7x plus 3. And 2 binomials became a trinomial like we're used to. If we look over at number 2, we now have 2x times 3x is 6x squared. 2x times 5 is plus 10x. 3 times 3 is plus 9x. 3 times 5 is plus 15. We collect our like terms, and this becomes 6x squared plus 19x plus 15. Awesome. That's just a reminder that when we multiply, 2 binomials become a trinomial. 2 binomials became a trinomial. Cool. We're going to factor again. But there's a difference in the factor we're about to do versus the factor we've done before. The difference is when I start my question, I know that these trinomials, this trinomial right here, I know it's going to become 2 binomials. I know it. Right? That's how it always works out. And I also know that the first term of my trinomial always comes from these 2 terms right here. But we have a new problem. On all the previous questions, there never used to be a number here. It used to just always be x and x becomes x squared. But now there's a 2. So that means one of these has to be 2. And I know that to be true because if we look at the example above, for instance, my 2x squared came from 2x times 1x. Right? One of them had to have a 2 in front of it. That's the only way to get that 2x squared. So if I look down here, that means one of these has to have a 2 in front of it. I don't know which one though. And that is a problem for us. So what we're going to do is we're going to put a 2 into each of those spots. And we know that's wrong. Right? We know it. We know it's wrong to have 2 2's because that would multiply to be 4x squared. But we're going to make that mistake anyway, and we're going to fix it later. I then am going to continue with my regular diamond method to find the next 2 blanks. My diamond method is numbers that go on the side of the diamond. They have to multiply to be the top and add to be the bottom. The top is a times c. A times c would be 8. Right? Remember, a is 2, c is 4. 2 times 4 is 8. On the bottom of my diamond is my b value, which is 7. Two numbers that multiply to be 8 and add to be 7 is 8. Oh, hold up. It's the same question as before, and I made the same typo. I really apologize about these typos. That's supposed to be a 5, which means the top of my diamond is not an 8. The top of my diamond is a 10. Right? 2 times 5 is 10. Holy my goodness. It's embarrassing. Okay, two numbers that multiply to be 10 and add to be 7 would be 5 and 2. Those numbers still go in here, just like normal. Awesome. That is not my answer. Right? The reason I know it's not my answer is because I know that these 2's are wrong. Right? Remember, I can't have both of them. So I need to correct my mistake. So what we're going to do to correct our mistake is we are going to divide one of those binomials by 2. If I tried to divide this one by 2, 5 doesn't divide by 2, so that does not work. If I tried to divide the second one by 2, it does work. 2 can divide by 2, and 2 can divide by 2. So this becomes 2x plus 5, 1x plus 1. And that is my factored trinomial. I call this strategy diamond and correct because we're still going to do the diamond method, but we're purposely going to make a mistake on the a value, and then we're going to correct our mistake on the a value. We'll try another one. Let's try this one. So I have to factor a trinomial. I know trinomials always turn into two binomials. Always. I also know that this first term always comes from the first terms of my binomials. The problem is this 3. So that 3 has to be in one of these binomials, but I don't know which binomial. So I put it in both, even though I know that's wrong, right? 3 times 3 is 9x squared, not 3x squared. So I know it's a mistake, but I'm going to fix it later. To find the sides of my binomials, I have to find the sides of my diamonds. The sides of my diamonds are two things that multiply to be the top and add to be the bottom. The top number would be 3 times 6, which is 18. The bottom number would be 11, which is your b value. Two numbers that multiply to be 18 and add to be 11 are 9 and 2. So this becomes 3x plus 9, 3x plus 2. Like that. Perfect. I know that's not my final answer. The reason I know it's not my final answer is because there's no way that I should have 2 3's. 3 times 3 is 9x squared, which I know is not the first term. So I have to fix my mistake of having 2 3's. The way I fix my mistake is by dividing one of my binomials by 3. Only one of them should work. This doesn't divide by 3 nicely. That doesn't work. But if I look at my other binomial, it does divide by 3 nicely. That would leave me with x plus 3, 3x plus 2. And that is a factored trinomial. It's called diamond and correct. Right? I do my diamond method, and then I fix my mistake to get the proper a value. We'll try this one over here. So I start off by going, I know a trinomial becomes two binomials. Then I say to myself, I know this x squared comes from the first terms. I also know this 6 comes from the first terms, but I'm not sure which one. So I put the 6 on both. I know that's wrong. I will fix that later. My diamond method. I'm looking for two numbers that multiply to be the top and add to be the bottom. The top is 6 times 15, which would be 90. The bottom is your b value, which is 19. Two numbers that multiply to be 90 are 9 and 10. Those numbers multiply to be 90 and add to be 19. So this is 6 plus 9, 6x plus 10. Perfect. Now, I have to go back to my binomials, and I need to fix this, right? I need to fix that mistake. I fix it by dividing one of these by 6. But now we got a problem. This one doesn't divide by 6 because 9 divided by 6 doesn't work. And this one doesn't divide by 6 because 10 divided by 6 doesn't work. So instead of dividing by 6, I need to divide by two numbers that multiply to be 6. One of those numbers comes out of the first binomial. The other number comes out of the second binomial. So two numbers that multiply to be 6 are 3 and 2. And you'll notice the first binomial does divide by 3. It leaves me with 2x plus 3. And the second binomial does divide by 2, leaving me with 3x plus 5. And you'll notice 2x times 3x gives you 6x squared. So my first term still makes sense. That is diamond and correct when the a value has to be broken into pieces to divide out. Fantastic. All right. Number 8 over here is a beautiful question. The reason why is because people get ahead of themselves and they look at that and they say, hey, there's 3 terms, and they start doing diamond method. But they forgot that the first thing you always do is you look for a greatest common factor. So you need to look at your trinomial and find if there's a number that can divide out of all 3. And there is. All 3 of these divide by 5. That makes this 5 go out front. Actually, I want to do that in blue still. And then I'm left with x squared plus 2x plus 3. And then I can factor my trinomial. When I factor that, I'm looking for numbers that multiply to be 3 and add to be 2. Mr. Kennedy, I did it again. I've had typos all over this place, and I apologize. Sincerely, I do. This should have been 15. This should have been 10. Which means this is 3 here, and this is 2 here. Reversing my diamond a little bit. So now I'm looking for things that multiply to be 2 and add to be 3. The sides of the diamond would be 2 and 1, making my final answer. There's still a 5 out front. Then I have x plus 2, and then I have x plus 1. The x's multiply together to become x squared. The 2 and the 1 multiply together to be 2. And if you added these two together, it becomes 3. That is my final answer. You are now, hopefully, a Diamond Method pro. All right, make sure you do your practice. Next week we have one more type of factoring, and then we are done the unit, and we'll have a little bit of study time before our test on Friday. Take care of yourselves. I hope to talk and see you soon. I've seen some of you guys around. I really do enjoy it. So if you see me, say hi. Pop in, talk to me. I'd appreciate it. Take care, guys.